Here's your quick review of oxidation numbers, which will help us get ready to keep track of electrons during reactions so we can understand those reactions better. Oxidation numbers aren't really real. They're just a bookkeeping tool to help us determine which element is oxidized and which element is reduced. For ionic compounds, the oxidation number is the actual charge for any one of the monatomic ions. If electrons are shared, as in a molecular compound or within a polyatomic ion where there's covalent bonding, the oxidation number is a set of rules that chemists have made up, and the oxidation number is the pseudocharge that an atom would have if the electrons were assigned to the element that has the highest electronegativity, or in other words, the element that is hogging the electrons more. So we have a few rules that we'll need to be able to assign oxidation numbers effectively. Elements in their standard state will have an oxidation number of 0. As we said before, oxidation numbers are real for monatomic ions. It's the actual charge of any particular ion. Then there's really only 3 more rules. If we understand that the sum of the oxidation numbers must add up to the charge of the species, meaning if it's a neutral molecule, the oxidation numbers will add up to 0, or if we're looking at oxidation numbers within a polyatomic ion, the oxidation numbers will add up to the charge of the polyatomic ion. So here's the rules that we should apply in this order. Again, fluorine is most electronegative, so fluorine will always have an oxidation number of -1 unless it's in its elemental state of F2, standard elemental state. Hydrogen will have an oxidation state of +1, and again unless it's in H2 in its elemental state as diatomic hydrogen gas, or unless it's bonded with a metal. We won't likely see that on the AP exam. Oxygen will be a -2. Again, unless it's in its elemental state of diatomic oxygen, or unless it's a peroxide. You would be told it's a peroxide, with the exception of hydrogen peroxide. We certainly want to be well aware that oxygen in hydrogen peroxide carries an oxidation state of -1. This should be enough to allow you to be successful assigning oxidation numbers.